Good day, students. This is Mr. Morales, and I'll be explaining to you finally a new topic for Algebra 2. Well, it's new in the sense that it's just an extension of where we left off before we went on a spring break and everything else that went down. So we're going to continue with exponential equations, and we're going to learn how to solve just the equations. So we're going to move away from the graphs and just go back into some basic algebraic problem solving. So we have three main sets of notes here. The first one says, use the properties of exponents to simplify each side of the equation. I included a JPEG picture in this posting, so you can always look at that, or you can always just Google search properties of exponents and find a multitude of examples of the rules in case you don't remember them. But you don't need too many of them except for like maybe one or two. The second rule here is rewrite the equation so both sides have the same base. You're going to have to know what I'm talking about when I say base. And I think if you watch enough of the examples, you'll know that it's the big part of the number and not the small part, the exponent. And then rule 3 is drop the bases and set the exponents equal to each other. By dropping the bases, it means we're going to be able to ignore them at some point. And we'll start with our examples. If you're wondering why my notes are covered up, it's because what I have are the nice, really formal version of the notes. Because we have so many examples that I want to go through, it'll take even longer in recording this video if I write out all the problems by hand as well when I solve them. So what I'm going to do is I'll show you the problems as they're worked out and explain step by step what we do to solve them. So if we start with our first problem, and you notice it says type 1, equations with a common base. So that's these problems right here, where we have 2 to the x plus 1 and 2 to the 9th. The 2 is the base, and they're common because they're the same. Same thing over here with the 5s on number 2. Pardon the noise. I have my dogs in here with me, so if you hear the occasional, collar tag shaking in the background, you'll know why. All right, so back to my examples. So I have 2 to the x plus 1 equals 2 to the 9th. That's our first example. Well, you're going to see here that it's really quite easy. When you have the same base, Part 3, Rule 3 up here says you can just drop it, which means you can pretty much just ignore those bases. So just deal with the exponents. On the left side, I have x plus 1, and then equals comes down also. On the right side, my exponent is a 9. So I set the left exponent equal to the right-hand exponent because they had a common base. Now it's just a matter of solving with algebra. You have x plus 1 equals 9. Well, to get x, you would subtract 1 from each side, and you would get x equals 8. For number 2, it's the exact same type of thing. We have a common base of 5 for both of these problems. So then what I'm going to do is I'm going to set the left-hand exponent equal to the right-hand side exponent. So I get 4n plus 5 equals n minus 7. Now it's just a matter of combining like terms. So we subtracted the n from the right and from the left, which gives us 3n's plus 5's equals negative 7. And then I'm going to go ahead and move the plus 5 to the other side by subtracting it. Minus 5 here, and negative 7 minus 5 gives me a negative 12. Now I have 3n equals negative 12. I'll go ahead and solve for n by dividing both sides by 3. And when I divide both sides by 3, you get n equals negative 4. You're going to notice that in a lot of these notes, in order to save time, I'm not necessarily showing every single step, but I will be explaining, because at this point in Algebra 2, you should know how to solve your basic two-step equations without needing to see every little in-between step. Now, for number 3 and 4, we have the same bases again, and it's going to be the exact same idea. What makes number 3 different is now we have 2 terms on the left side equals 1 term on the right side. Up above, we only had 1 term on the left and 1 term on the right of the equal sign. So here's where we have to use our first exponent property. Our rules of exponents say that when we have the same base but different exponents, we add them, and that's exactly what happens here. They took the first base, which was k, right here, and they added to the second set of exponents, k plus 2. So we have the first k plus the k plus 2 that was found in the second exponent. That equals the exponent on the right side, 5k minus 1. Remember, you can only do this when you have a common base. In this case, the common base was 3. And so we just drop it and look at the exponents only. Now I just combine like terms. And I'm going to have k plus 2, which is 2k's plus 2, equals 5k minus 1. And then I'm going to go ahead and just combine my like terms. So what I'm going to do is subtract 2k from both sides. I end up with 3k's over here. I added this one to the left side, and I get 3. 3k equals 3. You divide both sides by 3, and you get k equals 1. For number 4, here we don't have any x's on the left side in the exponents. They're all over on the right side, or excuse me, not x's, variables, because it can be any letter, not necessarily x. But it's the same rule. If we have the same base and we're multiplying them with different exponents, then we're going to add those different exponents. So I have negative 4 plus 9 equals, on the left side right here, I have v plus 4. I'm going to add that to the right side exponent, which is 2v minus 11. So it just becomes one long univariable equation. I'm going to combine my like terms on the left and right side. So negative 4 plus 9 gives me a 5. V plus these other two v's gives me 3 v's. 4 minus 11 is a negative 7. Now I will go ahead and just bring my minus 7 to the other side by adding 7. And I get 7 plus 5, which is 12. 12 divided by the 3 and the 3v gives me v equals to 4. So for these first 4 examples, these are the best case scenarios you're going to see on your assignment. And these are actually the way the first, I believe more or less the first 4 are set up. All right. Although you are going to need some further explanation, which is why we have more notes going on, how to handle different other types of situations. So now let's go on to the majority of our examples, which are going to be type 2. Equations without a common base. Usually when you see this kind of thing, you're probably thinking dread, like I'm going to have so much more work I have to do now, but really it isn't. Well, it isn't asterisks. If you know your times tables, at least your 2s, 3s, and 4s, you know, your 6s maybe, your basic times tables, then this should be pretty fast and easy. If you're not that fluent with your times tables, well then maybe you're going to pull up a multiplication chart, and then let's just be honest, we have a lot of free time. Learn your times tables. It can't hurt. It'll make life a lot easier in the long run, trust. So back to our examples now. So for numbers 5 and 6, here we have examples that don't have a common base. For number 5, I have a base of 6 on the left side, but a whole number of 36. Well, the idea is then, is there any way you can rewrite them both sides to have a common base? Well, I already have a base of 6 over here, so I asked myself, is there any way I can rewrite this 36 as an exponent with a base of 6? And if you know your times tables, you know you sure can. You can rewrite it as 6 squared is the same thing as 36. Once I do that, now I have the left and the right side. I have common bases everywhere. And just like the examples above, once you have a common base, you can ignore the base and just work out the exponent. So in this case, once I have a common base of 6, then I can just go ahead and solve the equation 2x minus 10 equals 2. You would add 10 to both sides, so you get 2x equals 12. You divide both sides by 2, and you get x equals 6. Not too bad. Just because it was a little different, required a little extra step in thinking, but it wasn't anything we couldn't handle. For number 6 now, we have 2 to the p minus 7 equals 8. I have a base of 2, so you want to ask yourself, can I rewrite 8 as a exponent with a base of 2? And 2 times 2 is 4, times 2 again, that's 3 of them, is going to be 2 to the 3rd power. So you can rewrite you can rewrite 8 as a power of 2. So you would have on the left side 2 to the p minus 7, that didn't change. All we did was rewrite the 8 as a base of 2. So we have 2 to the 3rd power. Once they have a common base, you can ignore or drop them and just solve the resulting equation. P minus 7 equals 3. You would add 7 to both sides and you get p equals 10. Not too bad. We're about, a third of the way through our notes? Let's go on to numbers 7 and 8. Now for number 7, here, I know I should do the answer, but whatever. For number 7, what makes it different is we have a fraction on the right-hand side. But you have to remember your rules or properties of exponents. A fraction just means you have a negative exponent involved. So the rule here is whenever you have 1 over any number, you can rewrite it as that denominator to the negative 1 power. So making it a negative 1 power means it's a fraction. They're the same exact thing. Like I said, feel free to review that rule of the properties of exponents to refresh your memory. Once I've done that, I see automatically I have a common base of 7. So I can go ahead and drop the 7s and then just solve the resulting equation that's left over in the exponents. 4x plus 11 equals negative 1. I go ahead and subtract 11 from both sides. I get 4x equals negative 12. Solve for x, you get x equals negative 3. For number 8, this goes back to number 5 and 6 from above. have a base of 2 on the right-hand side, but I have no base over here. But I do have a 32. Well, I asked myself, how many times would 2 go into 32? I know since it's even, it's going to go into it a specific number of times. So I can rewrite it. So I would say 32 divided by 2 is 16. All right. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2, and I have my fingers here because I'm counting, is 5. So I can say 2 to the 5th power is the same thing as 32. So 2 to the 5th power on the left side equals 2 to the 2m minus 9 power on the right side. Once again, I have common bases, so I can just go ahead and ignore them and solve the resulting equation. 5 equals 2m minus 9. You add 9 to both sides, you get 14 equals 2m. Divide both sides by 2, and you get m equals 7. So far, so good, I hope. Hopefully nothing's too complicated about this. Number 9 and 10. So here, same exact thing again. I have 2 different bases now, 27 and 3. You always want to ask yourself, which is the smallest base that I can make this? Because you want to make your life a lot easier. Well, 27 can be divided by 3. And as a matter of fact, to get a 27, you would need 3 to the 3rd power. So what they did is they took this whole number and they made it its own separate exponent inside parentheses. And they made it using the base we have right here of 3. So 27 divided by 3 is 9, and 9 divided by 3 is 3. So there was 3 groups of 3's in there. So 27 is the exact same thing as 3 to the 3rd power. Now you have 3 to the 3rd power in parentheses, but you still have the exponent on the outside, 2x plus 6. We'll talk about what rule you're going to use right now, but let's go ahead and just keep working out or simplifying it. The right side is still just 3 to the 2x. Well, in our properties of exponents, there was, I forget, I think it was the product rule, or I think it was the product, one of the rules there. When you have the parentheses, you multiply what's inside the parentheses times what's outside the parentheses. So 3, oh, by the way, we dropped the big base 3. So now I have 3 times 2x, which is 6x, and 3 times 6, which is 18. And then I have 2x over here on the right-hand side. So it was just a matter of simplification, really. So here we did a little bit of distributive property. I took the exponent that was attached inside, and I multiplied it times each term outside right there. Once I did that, I just go ahead and set it equal to what was remaining over here, which was 2x. And I just solved it like you would a regular two-step equation. So you're going to subtract, what is it, 6x's from both. I mean, you're going to add 6x's to both sides. What did we do here? I have a minus sign right here. I'm not sure if I wanted to keep that there. Oh yeah, so I subtracted 6. So 2 minus 6 is negative 4. There we go. And the 18 falls down. You divide both sides by negative 4. And you get a fraction answer. For the Google form, and I'll just make a little star here for those of you who are actually paying attention, I want you to give me the decimal answers because I'm not sure that the forms can set up between fraction and decimal. So let's keep it safe and make it decimal. What is half of negative 9? Well, that would be negative 4.5. Here's my next bit of advice. To get full credit, anything that's going to have a decimal part, go up to and no more than 2 decimal places. So yes, you could have easily said 4.5, but I'm going to set up the Google form to respond to 2 decimal place answers. I'm not sure if it'll automatically interpret that there should be a 0 here or not. So if you don't have a second digit to put right here, then just throw in a 0 place filler so your answer looks like this. 2 decimal places. All right, when you give me your Google form answer. Number 10, going on. So we'll go step by step. I have a base of 4 on the left, and I have 16 over here. I know automatically that 16 is divisible by 4. As a matter of fact, I know 4 squared is 16. So I'll rewrite the equation, but instead of saying 16, I'm just going to say 4 squared. So I have 4 to the y plus 2, nothing changed there. I rewrote 16 as 4 squared, and because it was rewritten, I put it in parentheses. It keeps the same exponent I had above, y minus 3. Now that I have a common base, I can go ahead and just drop them. And on the left side, I will have y plus 2. And on the outside, I'm going to have 2 times y, which is 2y, 2 times negative 3, which is negative 6. Now it's just a matter of combining my like terms. So I'll bring the plus 6 to both sides. I get y plus 8 equals 2y. And then I'm going to go ahead and subtract the y from the left, and I get 8 equals y. So we're halfway through the notes now. Hopefully this hasn't been too complicated. I highly recommend that you go back and revisit this video for any of the things that maybe you had a question on, especially when you see similar examples in your assignment. One quick thing is, how do you check your own work? And I totally was skipping all over this. Well, you would just plug in your answer. For example, up here on the top, to check your work, you get x equals 8. Well, wherever you see an x, plug in an 8. What's 8 plus 1? 9. Does 2 to the 9th equal 2 to the 9th? It sure does. So as long as you get the same thing on the left and right side of your exponents when you plug them in, you'll have a right answer. You can even do each piece one at a time. You can ask yourself, what is 2 to the 9th? You'll get some big number. And then you'll say, okay, what is 2 to the 8 plus 1 power? And you get the same exact matching number. That's how you can check your own work. Same thing with any example, even the ones down here, where it says, like, let's say x equals 6. We'll plug in a 6 right here. 2 times 6 would be 12. 12 minus 10 would be 2. So that would give you 6 squared. 6 squared is 36. So it would be a true statement. You can check your own work as you go along. So it really there's not really too many reasons why you should go wrong, unless you're just missing an algebraic step. All right, but you should be confident enough to be able to check your own assignment. So let's go ahead and go on to the back. And as I continue with this video, I am seriously wondering how many examples I'm going to end up giving you in total, or how many problems I'm going to give you in total, but we'll talk about that towards the end. So let me go and get my papers out. Yes, I know the answers are exposed, but that's not as important as understanding why. So number 11, I have 125 to the y power, and then I have equals 25. So neither of these have a nice small base, but I do know they have something very much in common, and that would be the number 5. So I have to figure out, how can I rewrite 125 as a power of 5, and how can I write 25 as a power of 5? Well, automatically, I know at least 25 is 5 squared, so I have that right here. To get the 125, I just keep dividing it by 5 and count how many times I do it. Or you can just play with the calculator and say 5 to the second, 5 to the third, 5, whatever, until you get to the number you want. So I have 125 is the same thing as 5 to the third power. Because it's been converted, I'll put it in parentheses. The reason why the right-hand side is not in parentheses is because there's nothing else attached. 25 was by itself, so I don't have to separate it from anything else. However, I have 125 to the y power, so I have to separate 5 to the third, parentheses, to the y power. Common base means I can just drop them, and I get 3 times y, which is 3y equals 2, because remember the 5s went away, we dropped them. And then once again, we get a decimal answer. And here's another little rule for getting your right answer in the Google form. A little star there. Here, 2/3 would be the decimal 0.666, and it goes on infinitely. Well, like I said, I only want 2 decimal places. So literally just give me the 0.66. I don't have to even round it. I know it would be 0.67 if you're rounding. Give me the 0.66 and we'll be fine. You don't have to do any rounding. Just give me literally the second decimal place if there's one that exists, period. All right, going on to number 12. I have 16 to the 3x power equals 8 to the x plus 2. Both of these numbers are even, so automatically I'm going to try to go for a base of 2. And I have that here. 16 is 2 to the 4th power, which I'll put in parentheses, and 8 is 2 to the 3rd power, which also goes into parentheses. The stuff that was outside the original exponents come outside of the parentheses. Now that I have a common base, I can go ahead and drop the common base. Anything that remains inside, I can go ahead and multiply the inside exponent times the outside exponent. Now that I have my common base of 2 removed, I'll go ahead and distribute the 4 times the 3x, which is going to give me 12x. 3 times x is 3x. 3 times positive 2 is positive 6. Sorry if you heard a glitch there. You weren't going crazy. My TV went on in the other room, so I had to go turn it off really quick and pause the video. Luckily, with this program, I can edit pretty decently. All right, now, once again, I go ahead and just solve this, combine my like terms, and solve for my variable. X equals 2/3 again. So remember, when you put it into your Google form, you put in 0.66, no rounding required. All right, number 13 and 14. Here I have 4 to the 3x equals 8 to the x minus 1. Both even numbers, I'm going to try to go for a base of 2. I know to get a 4, it's going to be 2 squared, so I'll put that in parentheses. To get an 8, that's 2 to the third power, also in parentheses, because they have exponents attached. The 3x comes down, the x minus 1 comes down. Once I have a common base, I can go ahead and cross out the common base. Use some distributive property. 2 times 3x is 6x. 3 times x minus 1 is 3x minus 3. Combine like terms. So I subtract 3x from both sides. Go ahead and solve for or isolate my variable, as we say in Algebra 1, and x gives you negative 1. Over here, I got a couple of rules I have to remember now. So I have 81 to the 2x plus 5 power, and then I have 1/3 to the 2x power. Remember, first of all, get rid of the fractions by rewriting it as a negative exponent. So, and then, since I know I'm going to have 3 to the negative 1 power, I want to rewrite my 81 also as a power of 3, which is what we did over here on the left-hand side. You have to know your times tables, and you should know that 81 is divisible by 3. If you're automatically given something like this, here's a little hint. If they give you a base before they give you another base, and that's kind of what they did right here, use it. It should be, it's kind of a clue. They're not going to give you anything that's unsolvable in this assignment whatsoever. So you should be able to easily get a common base with just a little bit of mental thought, a little persistence. Once I have my common base, I'll go ahead and drop them. Distribute the left side. 4 times 2x will be 8x. 4 times 5 will be 20. Negative 1 times 2x will be a negative 2x. Be careful with those negatives. You guys are really good about doing a lot of the algebra, but negatives sometimes still throw some of you off. Go ahead and solve by combining your like terms. So I put the x's together. I get negative 10x's after I subtracted the 8 from the left. And then I go ahead and just simplify and isolate my variable. I get x equals negative 2. Moving on, number 15 and 16. So once again, I have no common base for number 15. I have an 8 on the left, a 32, but they're both even, so I know I can write them both as base 2. So I'll rewrite the 8 as 2 to the third power, and I'll rewrite the 32 as 2 to the fifth power. They both keep the exponents that came in front, the 2a minus 1 over here and the 2a plus 1 over here. You go ahead and once you have a common base, you can drop it. Make sure you distribute the inside exponent times the outside exponent. 3 times 2a minus 1 will give you 6a minus 3. And 5 times 2a plus 1 will give you 10a plus 5. Combine like terms, isolate your variable, and you get a equals negative 2. Whoops, let me move it up a bit. For number 16, we have 27 to the 2x equals 243 to the x minus 2. 27 is not an even number. So when you don't have an even number, and if it doesn't end in 5, go to the odd number right after 2. Go for 3. Both 27 and 243 in this case can be written as multiples or exponents of 3. 27 is 3 to the third power with the 2x still attached. And 243, which I didn't even know, is 3 to the fifth power. But I would know that 27 is divisible by 3. So this is why I would have started manually anyways had I not the answer key to begin with. So now that I have a common base on both sides, I can go ahead and drop it. Distribute the remaining exponents, the inside times the outside parentheses. 3 times 2x is 6x. Inside times the outside, 5x minus 10. Combine like terms, isolate your variable, and you get x equals negative 10. Number 17, going on. We're almost done. I know it's a long video, guys. It's almost like a regular class, isn't it? Only I can't see any of you. But that's okay. I'm sure some of you guys are in your pajamas, and I don't want to see your bed head. Number 17. I, of course, am dressed in a full 3-piece suit, as you would expect, while making this video from home. All right, number 17 and 18. I have 64 equals, now I have two terms on the right. 4 times 4 to the 4x. I think we have a little clue here that we can probably rewrite the 64 as a power of 4. And indeed, we can. So we wrote everything with an exponent and a base of 4. So 64 is 4 to the third power. A single 4 means you have 4 to the first power. And then we had the regular 4 to the 4x that was over here. Common bases can now be all dropped, and we get 3 equals 1. Now remember, when you have two terms that were originally being multiplied, as we see right here, you are going to add them after you drop the bases. So you're going to have 1 plus 4x in this case. Go ahead and combine like terms, get that 1 over to the other side, divide by the 4, and you get 1/2. Remember, in the Google form, you're going to want to enter it as 0.50 because you want to have 2 decimal places for decimal answers. Number 18, I have 9 to the 2x plus 4 times 9 to the 2x equals 1 to the 81st power. Well, I do know I can write this as 81 to the negative 1, but 81 is still too big and I need a common base. Well, hint, hint, it's going to be 9, and I know my times tables, I know 9 goes into 81. So 9 squared is 81. So I know 9 squared, which is the 2 up here, and it gives you a 9 to the negative 2 power, basically, as I'm saying. So 1 over 81 is the same thing as saying 9 squared, or 9 to the negative 2 power. Now we have our bases, all 9. We can drop them. I'm going to add this to this. So 2x plus 4 plus 2x equals the negative 2. Combine like terms, you get 4x plus 4 equals negative 2. Subtract 4, you get 4x equals negative 6. Go ahead and isolate your variable. You get negative 3/2. In Google form, this would be negative 1.50. All right? And finally, yay, our last 2 examples. I know you can't get enough of my wonderful voice after almost a half hour of class discussion. Well, not really discussion, it's just me talking to myself. More like just my lecture. There we go, that sounds a little more academic. So, I have 1/7 equals 49 to the x minus 5 times 7 to the x minus 9. I see a common theme here of 7s, so let's rewrite everything with a base of 7. 1/7 I know will be 7 to the negative 1st power because it's a fraction. 49 is the square of 7, so 7 squared, and you're just bringing down that x minus 5 on the outside with it. And then 7 to the x minus 9 stays 7 to the x minus 9. Once I have all my common bases, I can just ignore them, and I have negative 1 on the left that remains. I'm going to add, well, first I need to distribute the inside exponent times the outside. So 2 times x is 2x, 2 times negative 5 is negative 10. Bam. That's going to get added to the x minus 9. I put parentheses just to show that there were 2 different pieces, but as you saw before, they weren't there, so you don't have to include new parentheses. I just wanted to demonstrate what I did. Combine your like terms, 2x's plus x is 3x, negative 10 plus negative 9 is negative 19 equals negative 1. Bring that negative 19 over with addition, and then divide by 3, you get x equals 6. And finally, my last example, yay, for the week, even better, right? We have is 4 to the 2x times 1 over 16 equals 4 to the 6x plus 18 power. Looks complicated, but it's not. Let's continue the pattern by now. I see a common base here of 4 happening somewhere. And since I have a fraction, I'm going to have a negative exponent especially. Well, how do you get a 16 with a 4? That's going to be 4 squared. But since it's on the bottom, it's going to be 4 to the negative 2 power, which you see right here. 4 to the 2x in the beginning is still 4 to the 2x because I had that base. And this had that base right there that I wanted a 4. Now that I have all my terms with the same base, I can go ahead and just drop that base. That sounds like I'm reading a song lyric or something for some reason. I'm just going to drop that base. Yes, DJ. And then I'm going to go ahead and add 2x minus 2. And then I have 6x plus 18. Go ahead and combine my like terms once again. And isolate my variable. And I get x equals negative 5. Well done. You've survived. You made it through this second week of distance learning, as I make my air quotes, for solving exponential equations. By all means, I will be online Tuesday and Thursday from 9:30 to 11:30 officially. I have meetings virtually, and I mean virtual meetings, not like pretend meetings. I have meetings online all day, most of the day on Wednesdays. But Mondays I'm pretty much available. Well, I really am available. And then of course, Thursdays like I'm already. But if you send a message in Google Classroom and it's not too late, I can pretty much respond to you whenever. So feel free to work on this assignment at your own discretion, and feel free to Google the topic of solving exponential equations in YouTube, not really Googling, I guess, search in YouTube, and you might find other examples or other teachers or instructors who have maybe a preferred way you might learn better with if this is still a little too unclear for you. However, don't not try this. Give it a chance, give it a shot. And if you get stuck, let me know. I can help you out, all right? Otherwise, answer the Google form. As of right now, as the recording of this video, I don't have a set way of grading yet. So the way I kind of explained it was, if you get more than, I think, 70% correct, then that counts as a completed assignment. And less than that will count as incomplete, but I'll be fairly lenient. If you when you do your work, however, let's say that happens. Let's say that you're struggling and you get like a 65%. In that case, if you save your work, I might ask you to show me what you did, and you showing me the work that you have done so far by hand, you know, with a picture or whatever, or just save the actual document in case I need to take a picture or you need to send me a picture of it. Then I can probably give you and justify giving you those extra points because I see the work happening. Because the Google form just gives me the answers that I'm looking at from you guys. But if you're one of those borderline kids and you need the extra points, showing me the work would be a good way to do it. All right. So best of luck. And I hope to hear from you guys or get some good feedback on this assignment from you guys soon. All right. Have a great day, week, and please take care of yourselves. Bye.